In question number 6, tells you to use the factor theorem to determine whether the given expression is a factor of each polynomial. Yesterday we learned that if you set this equal to 0, and I just solved this little problem here. Remember, you're using PEMDAS backwards to solve. So I would not divide by 3. You get x equals negative 4/3. Raise your hand if you got that. Okay, so now I'm going to take that number and I'm going to substitute it in for every x value. So now I put in negative 4/3. And I'm going to go ahead and simplify. Now I did ask if you guys could try to keep them as fractions as long as possible. Now I'm going to use PEMDAS to simplify. So exponents first, 4 to the 3rd power. What does that give me? 64? And then 3 to the 3rd power is 9. This is a negative expression squared. Now, this expression was cubed, right? So negative times negative times negative is still negative. This is going to become a positive. 4 squared is 16, and 3 squared is 9. Oh, 27. Good job, Jasmine. 3 cubed is 27, not 9. Not 3 times 3, which is the mistake I made. And then 18. Let's just write 18 times negative 4 times 3 plus 8. Okay, so I'm going to show you guys how I simplify my fractions. It looks kind of long, but I think you'll understand why they do things called cross-canceling. So I'm going to write 3 over 1 times negative 64 over 9 times 3. And then 16 I'm going to write as 16 over, I guess that's the same. And then I'm going to write 18 as 6 times 3. Plus 8. And you might be asking, why am I doing all this work with a fraction? Because they have a fraction. They actually didn't give us a decimal. I'm going to cancel my 3's there. So that one becomes negative 64 over 9. That one I'm just going to multiply, so 13 over 1. So I'm just going to multiply across 4 fractions. 208 over 9. My 3's I'm going to cancel here. So I have 6 times negative 4, which is negative 24, plus 8. For fractions, you just you're going to add the numerators at the top. So 208 minus 64. This gives me 144 over 9. And 24, that will give me negative 16. How do I get a nice fraction? I'm just going to put this one over 1. I'm going to multiply by 9 over 9. The reason why I'm doing this, so I have a common denominator. So 144 over 9. And negative 16 times 9 gives us negative 144 over 9. That's a 4. So I have a positive, I have a negative. That equals 0. So f of negative 4/3 equals 0. Yesterday we learned that if your remainder is 0, then is it a factor? Yes. Yes, it is a factor. So there's our statement. And then let's go ahead and draw a quick picture. Super fast sketch just to help us understand what's happening here. I have a odd degree polynomial because it is a power of 3. Gotta zoom way out. So that is a odd degree. So that means that based off of this number here, I'm going to start down and up. To improve on the accuracy of your graph, I have a y-intercept of +8. And this green line I'm drawing is telling me where negative x equals negative 4/3. And then the order pair. In fact, zoom back in for you. Negative 4/3, 0 is on this green line. It's actually on the x-axis itself. Super important. And then I can just sketch my points. And there's a quick sketch of my graph. So we had to work with a fraction. Question for those who tried to convert that to negative 1.33 and you put it in. Did it give you 0? No. Do you know why? No. Because it's rounding. Negative 1.3 is not good enough. You need negative 1.3 for all of the infinity long, and you still won't get 0 because you're always constantly rounding. Okay? So that's why I had to use fractions.